factoring. Last time we just started some simple factoring using the greatest common factor. Now we want to use that knowledge to start really weird factoring, like group factoring. Factoring.
Are we still on 5.4?
I think so. Okay, so we have this question: ax plus 2ay plus 2bx plus 4by. Oh, so we will choose two of them and then two of these terms. In first two terms, we find common term between these two. What is that? A. A. If you bring out A, what remains from the first term?
2xy. Only x plus 2y.
Just x plus what?
2y.
2y. Correct?
Mm-hmm.
Okay. So from the second one, so let's say between these two groups, they have a positive sign. Yeah. So from this one, what is the common between these two terms?
2b.
2.
Is that
2b.
Just b.
2b? Yeah, 2b. B is common, and then we have constant in common, which is 2, right?
Mm-hmm.
So 2b multiplies to,
X plus 2y.
from the first one, x remains. From the second one,
2y.
2y, right? Okay, so this was the first group, this is the second group. This is the first group, second group. From the first group and second group, can you see anything in common?
Yes.
What is that?
X plus 2y.
X plus 2y, correct? So imagine from these two groups, from each of them I'm bringing out this common factor. So, from the first group, which was this one, what remains? A remains, correct?
Yes.
From the second group, what remains?
2b.
Is that correct?
Wait. For the second term, where did you get the A from?
So, x plus 2y was common between both of them, right?
Yeah.
We brought this out. From the first group, if we bring out x plus 2y, A remains. From the second group, if we bring out x plus 2y, 2b remains. Wrote it down here. Okay? So, our first polynomial was this one, right? Now we have two parentheses. X plus 2y multiplies to a plus 2b. So we factor this polynomial using group factor or grouping. So you will match two terms together. So why I chose these two? Because I saw there is something common between these two, correct?
Yes.
So this is a group for me. These two, I see there is something common between these two, correct? So I use these two as one group. I couldn't solve it in another way because these don't have these four terms they don't have the same thing in common. Do you see that? Nothing is common between all 4 of them. So that's why I had to group them and factor them separately, and then at the end I could have 2 parentheses like this. So the other example, so if you look at all of these 4 terms, you cannot find anything in common with all of them. So x is common between these 3 terms, but not this one, right? Y is common between these 2, but not in these 2. And then constant 2 is common between these 3, but this one doesn't have any 2, right? So that's why we have to use grouping. Now, so between these 2, you will see there is something common. X is common, right? And also this one is 4 multiply 3, right?
Yes.
3 is common between these 2. So 3x is common between these 2. Okay? So let's keep this as a group. Between these 2, 2 is obviously common, right? What else is common? That's it, right?
Yeah.
So, this is one group. Bring out 2 from the first group. There are 2 terms. So bring out 2 from this one, what remains?
X squared minus 9y.
Correct? Minus. So I want to show you how we can match them, okay? Because sometimes it goes wrong. Our groups are not correct. Sometimes our groups are correct. And then I will show you the kind of formula that tells you which groups are correct and which groups are not. Okay, so what can I bring out here? 3 what? X multiplies 2. So what remains from the first one? 4 remains, correct?
Yes. X, Y.
And then plus
Y.
this one y, right? Is that correct? Because multiply this back, you will have 4 multiplied 3x, which is 12x, right? And then you brought out actually negative sign here, negative 3x. And then you told me positive y, which cannot be correct. Because if you go back, you will have negative 3xy, but you had positive 3xy, right? Do you see? So if you brought out negative sign, so this will change from positive to negative. Is this correct? So can we accept this as a group, this as a group? Look at this one. We don't have anything common between this, right? So all the purpose here when we group them was to see this common parenthesis between them, right? But here you don't see that. So what this tells us, our group was not correct. So these 2 together, this doesn't give us a good group. This one doesn't give us a good group. So look at this. If between these 2 you said A is common, the ratio of this coefficient means this x, this 2y, because 2y remains from this term. You will have x divided by 2y, right? If A is common between these 2. The first ratio, the first coefficient is x, the second coefficient is 2y. Am I right? Do you see what I say? So the common between these 2 was A, right? The coefficient from the first one was x, from the second one was 2y. Am I right? So now look at this group. What was common between these two, you said? 2b was common, right? So 2b was common. From the first one, what remains? X, right? This is the coefficient of first term. So from the second one, what remains? 2y. Compare this ratio with this ratio. Do you see that? Both of ratios are the same. These ratios tell us that our group are matched. They are correct. Do you understand? So the ratio of coefficient, when we bring out the same or common factor, should be exact same as ratio of the second group. But here, doesn't happen. So let's say 2 is common between these two, you said, right? So what is the coefficient of the first one? X squared, right? And then what remains from the second one? Negative 9y, right? This is the ratio of the coefficients, correct? So now this one, what was common between these two? 3x was common, right? So what is the coefficient of the first term? Negative 4, right?
Oh yeah.
Is that correct? And then what is the coefficient of second one?
Y.
Just y.
Oh, just y.
Yeah, that's
Oh, yeah,
So
it's X
compare
is
the
X.
coefficients and ratio of coefficients. They are not similar, right? So from the first step, we could say, if we found the ratio of coefficient, we could say if our group is correct or not. So now, by just switching some of these variables, not actually switching, rearranging this, we can have a good group. Like this one is showing, if we have 2x squared minus 18 y minus 12x plus 3xy. So it says, let's bring 12x beside this one, match them together, and say this is a group, because we can move them, we can rearrange them, right? And then let's say these two together are groups. So let's rearrange it to 2x squared minus 12x minus 18y plus 3xy.
You can rearrange it.
Yes. If you want to write down the same as that one, you can, but doesn't matter. This is 3xy first, and this one, 18y is the same. Okay, so now we have this as a group, this one as a group. Correct? So I want to look at the ratio first to see if we have a correct group. So from these two, what is common? 2x is common, correct? So what remains from the first one? X remains, correct? From 2x, x remains. And then from the second one, what remains? Negative 6 remains, right?
Yes.
Okay, so this is a ratio of coefficients, right? For the first group. Second group, what is common between these two? I see y is common, and then what else? 4? 6? 3, right?
No, 6.
6.
6 times 3 is 18.
But you can. But it's common.
What is common
So
between these two?
3. Yeah, 3.
3.
Because you only have
The
three,
smaller
you have to
one.
take 6 out of 3.
Yeah.
Oh.
So this is 6 multiplied 3, this is 3 multiplied 1, so 3 is common. So 3 is common between these two. 3y. 3y is common, correct?
Yes.
So what remains from the first term?
X.
What remains from the second term?
Negative 6.
Do you see that? Now ratios are correct. they are the same. So now it means these two groups are correct, and we can continue. Actually, when we do this, it helps us because, okay, now 2x is common factor, correct? What remains from the first term? We already saw it. X remains, right?
X minus 6? Oh my gosh.
Correct? And then from the second term, second group, we have 3y in common, right? X is coming out, and
Minus 6.
okay.
MG.
So now what is common between these two groups? X minus 6.
X minus
2x plus 3y. So, do you have any question now? Yes.
I'm talking the last part. I'm talking just x minus 6
Mm-hmm.
in the last part.
Mm-hmm.
Well,
You brought out 3y. 3y outside the parenthesis from this group. We said 3y is common between these two, right? 3y is out. Then divide this one by 3y. What remains?
Yeah.
X remains. Divide this one by 3y. What remains?
6.
Negative 6. Right? So now this one is common with this one. So now let's do one more thing. Same question. So now you know this is the correct answer, right?
Yeah.
And then you know previous one didn't give us a good group and it was not, giving us a correct answer. So now let me switch these two. So let's say you put negative 18 first and then 3xy second. Still we choose this one as a group, this one as a group, but I want to see what happens if we switch these two. Okay? Do you understand what I want to do? I'm just switching these two in this group, or what you call rearranging that. So negative 18 goes first. It was negative 18, right? 18y. And it will, no, not that, just there is kind of the
Plus 3.
what's that? Plus minus will change. Nothing will change that much, just plus minus. Okay, is this correct now? So, okay. So I didn't change any group. Groups are the same, right? Just in this group, I changed the location of these two terms. Okay? So now, what was common between these two?
2x.
2x. X remains, negative 6 remains. Right? Is this correct?
Yes.
So, what is common between these two, you said?
3y.
3y. So,
Oh.
3y is common, right? So what remains from the first term?
Negative 6.
Negative 6. What remains from the second term?
X.
Y.
Plus y. Or plus x.
Oh, because we were getting.
Okay. So is there anything common between these two groups now? No?
It's just the opposite way in the
Yeah,
second
they're the same.
parentheses.
So are they common or not?
Yes.
Oh, yeah.
Are they the same or not?
Yes.
They are the same. Just, this location of these two changed because the location of these two was different, right? So this is x minus 6 itself. So these two parentheses are still the same, right? So we can say, okay, if you want to be so precise and perfect, you will write it down in this way now. And now you can see, yes, these two are exact same. So now we are going to bring out this and same result, right? Do you have any question?
How do you know? How can you tell that's the right answer?
That's a correct answer.
Yeah,
Let's
how do you tell?
let's check it. How we check it?
One.
Exactly. Correct? So we will multiply this one to this one, multiply this one to this one, multiply this one to this one to this one, right? So let's multiply them. So x multiplied 2x gives us 2x squared, right? First outer. X multiplied 3y is 3xy, right? And then this 2. Negative 6 multiplied 2x is minus 12x. And then what remains? Last.
18.
Negative 6 that to 3y. Negative 18y. Is that correct?
Yes.
So how you know? You just check with the first result and you were right. You were correct. So just going backward means multiply them, use 4, you will get the correct answer. If it is correct, your answer should be exact same as the top part. Correct? Do you have any question? Okay.
So when you factor, like, do you just know, like, that's the greatest common factor, or you just kind of pull it out of the?
You don't do that randomly. You will look at these two. What is common between these two?
6.
There is a constant which is common.
I mean 2.
2 is common between these two, correct?
Yes.
Why 2 is common? Because this one is 2 multiply something. This one can be 2 multiply 6 multiply something, right? So 2 is common between these two. And then between these two, there is a variable also common. X. You have x here. You have x multiply x here, right? So the x is common between these two. So, yeah, it's not random. You will look at them to see what is exactly common. The greatest common factor comes out. Okay, let's do this. xy plus 3x
Where are you looking?
Right there.
Right there. Example 7.
plus 3x minus 2y. Let's do this. xy minus 6 plus 3x minus 2y.
Whoa.
How come you did that one
Wait.
instead of that?
Yeah, you said the other one. The xy plus 3x minus 2y minus 6. That's the one you did.
Hmm?
No, you said you were gonna do that one, but you did.
This one is that one.
It's the same thing.
They are both the same, right? The question was there,
So you just rearranged the terms, though.
and they started with rearranging them, right?
Yeah.
So that's it. They are same. So now I see that these two have y in common, correct?
Yes.
And then these two
Have
3 in common, right? We just want to try to see if we are correct and we are choosing the correct group. I don't want to just follow that, so I want to see what's the reason behind choosing, 12 terms as a group. Okay. So if I choose these two, let's put them together, and then let's put these two together. Okay. So I put constant at last because do you remember standard form of polynomial says just arrange them from the highest exponent of variable to the lowest. So let's put that in last as a constant because it's constant. Okay. Between these two, what is common? Y is common, right? So the ratio of the first one is X. Correct?
Yes.
The ratio of the first Y is X. What is the ratio of the next one?
2.
-2.
I'm sorry.
Correct? And then here. So what is common between these two?
3.
3 is common, right? So
X.
what is the ratio for 3 here?
X.
X. What is the ratio for -6 here?
-2.
Sorry, ratio for 3 here is -2. Right? So are these a correct group?
Yeah.
It is because the ratios are the same. Right? So we can continue like this. This is the correct one, this is the correct group. Because the ratios are the same. Right? So now we will bring Y out of these two. X remains -2. Correct? Is this correct?
Yeah.
So from the next group, 3 is common. X remains from the first term. What remains? -2. Correct? Between these two groups, X -2 is common, right? From the first group, Y remains
Plus 3 Y. Oh, I'm sorry. 5 plus 3.
correct? Do you have any question? Yes.
Would it work if you rearrange it to x, y? plus
Let's write it down.
3x?
Let's write. Yeah, because all of this will happen. So let's see what happens if we have different arrangement. Okay. Oh, actually, this one is different, huh? Is that? Is this the one you are asking?
Yeah.
Is this the exact same?
Yeah.
So, see how they solved it?
It's the same thing.
The same thing, right? Because if you find the ratio of the first group in compared to ratio of the second group, they will be exact same. So they are also correct one. So that's why we have the same result, right? Because the group they chose was same as, they gave us the same result as the group I chose. Correct? So do you understand what we were talking about? The group I chose is this group and this one, right? So the group they were choosing is xy and 3x. The other group is -2y, -6, which is different from group I chose. But they are correct because if you use that method ratio, it will give you exact same ratios. Oh, any question? So now we are going to start difficult.
Oh my god.
Factoring trinomial.
That's the worst.
Okay, what was trinomial?
3 terms.
It has 3 terms, exactly.
So sorry.
So it's a polynomial that has 3 terms. Do you remember? So we are going to factor trinomial with 3 terms. A polynomial with 3 terms. So from here, most of factoring methods we are using have a specific pattern and kind of a specific rule. So if we have this form, x squared plus bx plus c. So b was a number, c was a number. Correct? if you have something in this form, we can factor this using M and N kind of method. So what this method says, it says you can say this C is a number that includes M and N, and it says M multiply N can give us C. Here M, here N. So if we can write down C in this form of two numbers multiply each other gives us C, and using the same two numbers and say if B gives us the addition of M and N, we can write this polynomial or trinomial in this form using M and N. So write down this kind of method, and then we are going to understand everything using example. So for example, if you have x squared plus 9x plus 20 x squared without any coefficient, do you see that? Compare it. B is 9, right? C is 20. So if I can write this down, multiplication of two numbers, addition of two numbers, then I can factor it in this way. So what two numbers multiply to each other gives us 20?
5 and 4.
5 and 4, right?
Or-
What else?
or
There
10
are more of them.
10 and 2.
10 and 2. What else? I want to write down the list of them until after practicing
20 and
more
1.
questions you will understand, how to reduce and how save time. So I'm gonna start with 4 and 5,
2 and 10.
2 and 10,
20 and 1.
20 and 1. So why you are giving me all positive number? Because 4 multiplied 5 positive is 20, right? So what about negative 4, negative 5?
Yeah.
So I could write down negative 4, negative 5. Negative 4 multiply negative 5, right? So let me write it down in a better way. So 4 multiply 5. Negative 4 multiply negative 5. 2, 10. Negative 2, negative 10. 21. Negative 20 and negative 1. Right? Correct? So as you see, I started with C, means 20. I started with M multiply N, right? And then now, for each of these imaginary or kind of assumption, M and N, I will add them. So 4 plus 5 is 9. Negative 4 and negative 5 is negative 9. Correct? Continue. 12. Negative 12. 21. Negative 21. Am I right?
Yeah.
So those M and N were my assumption, right? I want to see if my assumptions were correct or not. So how I understand if they were which one of them is correct or not? The one gives us 9.
Because it's like the main number, kind of like the number in the
Question, right? So we started from C we write down all the assumption, and then we will match to see if this assumption gives us the b in the question, in this polynomial. So now, I know for sure m is 4, n is 5, or n is 4, m is 5, doesn't matter. So doesn't matter which one is m, which one is n. There were two numbers multiply each other, gave us this information, right? So now, equal to x plus m, x plus n, right? Okay, let me write down. So instead of m, I will write down 4. Instead of n, we will write down 5.
So what happened to the x squared?
Hmm?
Gives you that.
So x squared plus 9x plus 20 is these two parentheses multiply to each other. Because if you use FOIL and multiply all these terms, 4 terms together, what you will get? That one. Right? Question? Do you have any question? Nope? Okay. So whenever you see a trinomial like that, and remember this, x just has 1 as a coefficient. There is not any other numbers here.
In a trinomial.
Trinomial. If you see this form, you can use this method to break down the polynomial to 2 parentheses like that. Okay? So now next question. It says x squared minus 14x plus 24. X squared plus, negative 14x plus 24. Now, step by step, after we get used to, kind of writing down m, all of this, you will understand how to save time. So, if I want to say there were 2 numbers, gives us 24. What are those 2 numbers?
6 and 4.
6 and 4. Both of them are positive, right? 6 and 4. Negative 6 and negative 4 also gives us positive 24.
8 and 3.
So let's look at this first. So, these 2 numbers, almost similar, but the sign is different, right? So which one I should choose to save time, to not continue choosing the wrong sign over and over?
The first one.
The first one, add these 2 together. It's 10, right? The number you get after adding m and n should be a negative number, right? Is that correct?
No. I mean, yes.
Negative 14, so that should be a negative number. So if you add these 2 together, you will have negative 10. So those 2 numbers we add should give us negative number if we add them. Why? Because this one is negative, right?
Yes.
So we can just ignore all the positive multiply positive, right? We can just ignore them. So from now on, all the numbers that we are choosing, both of them will be negative. Because now we recognize that because of b, both numbers should be negative. Do you understand this?
Yes. But it doesn't equal 6, and when you add 6 and 4, it doesn't equal 4.
I'm not talking about this is the correct answer. We are still going to continue.
Oh, okay.
But because we are going to write down, for example, 12 combination, correct? Instead of 12 combination, now we have 6 because we know we are ignoring positive multiply positive, correct?
Yes.
So that's the reason. This is saving time. So now, these 2 numbers gives us 24. What else?
8 and 3.
Negative 12 times negative 2.
Negative 12 multiply negative 2.
And that's
Correct.
the answer.
So this is the answer.
Uh-huh.
But so 8 and 3 add together gives us negative 11. These two add together give us
Negative 14.
so that's why we choose this and this as a correct answer.
So it's x minus 12 and then x minus 2? I mean, yeah.
X minus 12, x minus 2. Even though we know this is x plus n, because the numbers we chose were negative, so negative replaced here will give us x minus 12, right? And x minus 2. Correct? This one. Solve it. Don't solve. No math.
Oh, solve that?
Yes.
Oh.
Which numbers you are choosing?
I don't know. What the heck?
Yes.
13 and negative 2.
13 and
Negative 2.
negative 2. Okay. So we add them together, we will have 11. That is the correct answer. Right? Okay, so instead of n, we have 13. And then here we have negative 2, and then we can, right? Is that correct? Next one. Oh, what are you saying? We have the same questions here. That's okay. Well, that's okay. Okay, so this one is good actually. Let's look at this one. So look at this. I said x squared plus bx plus c is x plus m, x plus n. Variable here is x, right? Is that correct?
Yeah.
So why we are doing this? Because if I tell you solve this polynomial, for example, if I tell you x squared plus 11x minus 26 equals 0, give me the answer for x, you cannot solve this that easy. You have to break this down to two parentheses, like x plus 13 multiply x minus 2. And then say these two parentheses multiply each other gives us 0, right? And then using zero product, do you remember I said a multiply b equal to 0? It says either a 0 or b 0. I talked about this, I remember. Do you remember?
Yes.
So using this, we will say either x plus 13 is 0 or x minus 2 is 0, right? And then we say, okay, solve this. X is negative 13. Solve this, x is equal to 2. X is either 2 or either negative 13, okay? What happens if I tell you, instead of x we have y, and I tell you solve this, what are the answers for y?
The same thing, because anything, because what you get for 26 is going to be what you get for 11 too.
Exactly. So answer would be exact same. I just changed the variable, right? Still, if you want to break down this polynomial, you will have y plus 13, y minus 2. Am I right?
Yeah.
You just changed the variable. You didn't change numbers, right? And then the answer for variable will be exact same. You are solving exact same thing, just, you know, instead of x, you have y. Instead of y, you have z. Instead of z, you have anything else. As long as the format is exact same, you can solve this for any, you know, variable, like anything here. Okay? So, if we have y squared plus bx plus by, we will have this. Yes? And it's not such a big deal. It's just changing variable, right? Changing variable is important. So as long as you understand what is the aim of doing this, solving for the variable, you will understand if I have something like x squared minus 2x squared, x cubed, x power 4, minus 24. I can change the variable here also. How? I can say, let's say, because this is almost same as this one, right? But changing something gives me the easiest way to solve this using this method, right? So let's say here instead of y squared, instead of x squared, I have y. Let's say instead of x squared, I have y. So for any x squared you have here, replace y. So this is easy. You will have 2y minus 24, right? So what should I write down instead of x power 4?
Y.
So I will show you here. If x power 2 is y, x power 2 is y squared, right? Is this correct?
So it's y squared.
So this is y squared. Is this correct? Do you understand this? Okay, so now it's easy. Just the same way you were solving this to break it down to two parentheses by factoring, use the same method to factor this. So the answer you get is y equals something, correct? So do that now. Break this down to y plus n, y plus n. Our m multiply n gives us 24, negative 24, and m plus n gives us negative 2. You should find those two numbers.
I found them. See how smart I am?
Okay, if you have the answer, raise your hand. So, tell me.
What?
Tell me.
Oh, x minus 6.
No. Tell me m and n. What is m, what is n?
Negative 6 and 4.
Yeah, negative 6 and 4.
Correct? Correct?
Yes.
Negative 6 and 4. So let's use negative 6 and negative 4. So negative 6 multiply negative 4 gives us negative 24. Negative 6 minus 4.
It's not negative 4.
It's
Which one is
positive
positive?
4.
4.
4 is
Negative.
positive.
4 is positive.
Yeah.
Is this correct now?
Yes.
So this gives us negative 24, and then combine these two gives us negative 2. So this is the correct answer, right? So let me write down n is negative 6, n is 4, right? So now we will write this down. Y minus 6 multiplied y plus 4, right?
Yes.
Oh, it's not x?
No, because you changed it to Y.
Exactly. So she's asking what about x? So we change this to this trinomial, right? And we solve this trinomial. So what was y previously? We should go back and replace it back, right? Do you understand what I say? So if we change the variable at first, we should put it back, correct? So at first we said x squared is y, we wrote this down, we solved this, and now everything is based on y. So what about the first trinomial we had, which was based on x? So at the end we have to have x, correct? How? But just by replacing back whatever, we change. So now we change it back to, instead of y, we should write down x what? Square. Because y is x squared, right?
Yeah.
So x squared minus 6 multiply x squared plus 4.
So only if you change the variable, you would go back to it and write that something.
You only need to change it because of other.
Mm-hmm.
You only, why do you need to change it? Because
Yeah.
it's the 4, right?
Because if I didn't change it, could you solve it? Could you solve this and break it down?
No.
No.
Because
You couldn't. So we changed it to make it in this form, and they say we already know how to solve this kind of polynomial, right? Because we just learned it, right? So that's why. So we changed it just to make it easier for us to solve it using the method we learned. Correct? You have a question?
No.
So this is maybe the most difficult in this part. If you understand this, everything is good. So we are right, x squared minus 6. So the final answer is x squared minus 6 multiply x squared plus 4. Correct? Okay, so this is good. So let's. Okay, 3x squared minus 30x plus 48. So this also teach us the basic step in factoring polynomial.
Wait, which one are we doing?
This one.
Oh.
This one. This has something basic in polynomial that you should always remember. I will keep this y because I'm going to use this. But before using this, we need a kind of a step before this one. Like the way we changed variable at first and then we use this. So now here also we are going to use one step before this one. So it says 3x power 2 minus 30x plus 48. And just as a kind of hint, we know that 48 is 3 multiply what?
16.
Okay? So we are going to use this information. 48 equals 3 multiply 16. So look at this, each of these terms. It seems similar to this one, but we have coefficient for x. Well, we can get rid of this kind of. How? Because we know 3 is common between all of them now. Because we know 48 is 3 multiplied 16, right? So what we do? Factor out 3.
So you can just simplify it?
Factoring out.
I'm sorry.
Factoring out 3 because, so simplifying means cancel, you get rid of some number, some variable, right? Factoring out means you're keeping this and you have to apply it later. You have to keep it up to the end, right? You're not simplifying. So 3 comes out. From the first term, what remains? 10 what? 10 plus 16, correct? So now you have a trinomial exact same as this one. Just solve this inside the parenthesis and break this down to 2 parentheses like x plus m, x plus n. Okay, but just keep in mind 3 stays outside.
So since it's in parentheses, would you still do the same thing like you do with the other trinomials?
Trying to stay awake.
What is m and n? Negative what?
Negative 8 and 2.
Negative 8, negative 2.
Negative 8, negatives? So, x minus 2, x minus 12, right?
12?
8?
8.
You said 8? 12. Okay. Who said 12? I heard 12. You heard some 12. Okay, so we have this, right?
Yes.
So don't forget this one. So, okay? So don't forget, if you bring out any common factor, you should keep it there. You're not canceling it. You're not get rid of that. Okay? So we have 3 multiply the first parenthesis, multiply the second parenthesis.
So you would just keep the 3 there? Or would you?
Yeah. Because now, if you go backward using FOIL, you have to multiply that answer to 3 to get this one, right? So that's the reason. Okay, this one. This is this. Okay, so that one was trinomial we were talking about. So do you still have your formula page? I said. So add this one. X squared plus x dx plus c is x plus m multiply x plus n. C is m multiply n. B is m plus n. So, okay, look at this. This trinomial we were talking about, that one I wrote down on the board, these are the same, right? We know these are the same. Just I changed the variable from y to x, from x to y. I said here, x or y, whatever variable we have, the leading coefficient, we call this leading coefficient, is 1 here, right? So you don't see anything. And here also, when you brought out 3, because you could bring out and factor this from each of terms, right? But sometimes, like this one, 2x squared plus 11x plus 12, you don't see any common constants to bring it out, right? Is that correct? So in this case, when you have a trinomial, but you cannot bring out the coefficient of x squared, you will use this new method that we are going to talk about. So this new method is combination of 2 different things. Okay, so our new formula is this. A x squared plus bx plus c.
Why we just use that, no? We didn't? Oh.
So we have a coefficient for x squared.
Oh.
So this will be equal to x plus something, x plus something else. But unlike that one here, I cannot give you a certain kind of formula because there is different steps we should follow. Okay, so the first step, let's use the same example. Was that 2x squared plus 11x plus 12? Let's use this. So we know this one is A, this one is B, this one is C, right? A, B, C, compared to this formula we have. The first step, multiply A to C. Multiply A to C. 2 multiply 12 gives us
24.
24. So the first step, multiply A to C. The second step, write down all the combination of the numbers multiply each other gives us 24, like 1, 24, negative 1, negative 24, 12, 2, negative 12, negative 2. Like before, we were finding m multiply n, correct? So now here you should do the same thing. So write down all the factors of 24 multiplies together gives you 24. So 12 multiplies 2, negative 12 multiply 2, and 6 multiply 4, negative 6 multiply negative 4,
Eight, 3.
8 and 3. That's enough for now. So the first step, multiply A to C. The second step, you are going to write down the same way as m multiply n. Write down the list of them. The next step, you are going to combine them, means add them. So these two gives us 14. This gives us negative 10. 10. Am I right? Oh, here it should be negative. See? This should be negative 2, right? Negative 12 multiplied negative 2 gives us 24, right? So that's why this one should be negative 14. So this step and the next step is same as previous method. So which one we accept? The one which gives us B, right?
8 and 3.
This one gives us B.
Wait, it's positive though. It's the
Oh, sorry.
first one.
This one. So I'm going to choose this. I'm going to choose 8 and 3. So 8x plus 3x gives us 11x. Is that correct?
Yes.
8x plus 3x gives us 11x. So all the point here is that to break down the bx, this one, break this down to 2 numbers. Now we have those 2 numbers, 8 and 3. So the next step will be like this. You are going to rewrite this to 2x squared plus 8x plus 3x plus 12. Do you have any questions so far? So now, if I give you something like this, can you use grouping to factor this?
Yeah.
You already learned that, right? So now, let's say this is group, this is group. Use grouping. What is common between these 2 terms in this group?
2x.
2x, right? Two x multiplied from the first term, what remains? Plus 4. So the second group, what is coming? 3 is coming. X remains
Plus 4.
right? So now, what is coming?
X plus 4.
X plus 4.
2x plus 3.
Correct?
Yeah.
So we are done. So this 2x squared plus 11x plus 12 is equal to x plus 4, 2x plus 3. If I tell you, solve this, what are the answers for x?
8 and 3.
Solve this for x.
Yeah.
If this one is equal 0, you will get x equal negative 4 and
4 and 3 over 2.
3 over 2. Right? These are the answer for x in this trinomial. So all the point to factor this polynomial was to find the answers for x. Right? So what we did, if we have a as a coefficient for x squared, we multiply a to c. We write down the multiplication, the number here. Write down the list of all numbers that gives us 24, right? And then add those 2 numbers to see if they match B. If they match B, now we break down B to 2 numbers. Then we use grouping to break this down to 2 parentheses. What time is it? 1 minute remains. While you pack. Do you have any question?
Why did you put x -4 and x -3?
So you will say this parenthesis equals 0 or this parenthesis equals 0. If you put x plus 4 equals 0, x equals -4. If 2x plus 3 is equals 0, x is equal -3 over 2. Do you have any question? So start on your assignment, okay? And you already should finish the previous sections, right? So, good. We'll see you on Wednesday. Still, we have to